Hello students, how are you? Hope so you are well and safe at home. So today on 22nd of October for class 12th in chemistry, we will start the new topic in chemical properties of aldehyde and ketones. In the last video we have discussed about the chemical properties of aldehyde and ketones and regarding with the nucleophilic addition reactions. Today we will start the second topic of chemical properties, that is reaction with ammonia and their derivatives. Okay, so the second chemical property is reaction with ammonia and their derivatives. So see here, first of all, what type of reactions are carried out in this reaction? So first of all, we see that any of the carbonyl group, that may be aldehyde or ketones. So any aldehydes or ketones will react with ammonia, like, and the derivatives. Derivatives means in place of Z, in place of hydrogen, there is a Z. Z means different groups. That may be hydrogen, that may be hydroxylamine, that may be semi-carbazide, that may be phenyl hydrogens, clear? And that may be 2,4-dinitrophenyl hydrogen also, clear? So there are different derivatives, okay? So what will happen here? This oxygen and hydrogen will be eliminated in the form of water. And this reaction is carried out in presence of 3.5 pH. Means weakly acidic medium. This reaction is carried out in presence of weak acidic medium. So it will convert into C double bond N bond H. Clear? Means this compound convert into I-beam. So when ammonia react with carbonyl compound, that will be aldehyde or ketones, it convert into imine with the elimination of one molecule of water. Actually this reaction proceed by the two steps: nucleophilic addition reactions with elimination reactions. पहले nucleophilic addition reactions होंगी और उसके बाद यहाँ पे elimination होता है water का. क्लियर? तो दो यहाँ पर साइमल्टेनियसली रिएक्शंस चलती हैं जब हम अमोनिया या अमोनिया के डेरिवेटिव्स के साथ रिएक्शन कराते हैं किसी भी एल्डिहाइड या कीटोन्स की. क्लियर? नाउ वी स्टार्ट द नेक्स्ट पार्ट, दैट इज जेड. व्हाट आर द जेड? दिस कंपाउंड इज नोन एज हाइड्रोक्सिलामीन. In this hydroxylamine, the value of the Z is OH. Clear? If we talk about the NH2 bond NH2, this compound is known as hydrazine. Clear? In this compound, the value of Z is this NH2. Okay? NH2 CO NH2 NH2 NHCO NH2. In this compound, this complete part NHCO NH2 represent to the value of the Z. Okay, so if any of the compound, that may be hydroxylamine, hydrazine, this compound is semi-carbazide. This compound is semi-carbazide. Okay, so when any of the aldehyde or ketone when react with hydroxylamine, so the removal of water will be takes place. H2 and oxygen and it again shows C double bond N. ये कॉमन फीचर है जो सब में बनेगा, क्या है वो, C double bond N. So this hydroxylamine convert into oxime. This compound is known as oxime. In the same manner, when react with hydrogen, these aldehyde or ketones eliminate one molecule of water and convert into C double bond N bond NH2. So phenyl, this hydrogen convert into hydrogen. In the same manner, this carbazide, that is semi-carbazide, after the removal of one molecule of water, it converts into semi-carbazone. C double bond N bond NH bond CO bond NH2, and this compound is known as semi-carbazone. Clear? So in each of the compound, that is derivatives of the ammonia, that is hydroxylamine, like that hydrogen, semi-carbazide, when react with aldehydes or ketones, eliminate water molecule and they fuse together by the C double bond N. Clear? Other than these, there are some compounds. Those are also belongs to the derivatives of the ammonia, like that NH2 NH with benzene. This compound is known as phenyl hydrogen. This compound is known as phenyl hydrogen. Clear? So in the same way, the water molecule will be eliminated and it will form phenyl hydrogen. The pH is the same, 3.5, means in the weak medium. C double bond N NH with the benzene ring. So this compound is known as phenyl hydrazone. Phenyl hydrazone. Clear? So when aldehydes or ketones react with phenyl hydrazine at the pH 3.5, it will convert into phenyl hydrazone. And see here again, C double bond N is present. Okay. If we talk about, there is an NO2 group at ortho or para position, NH2 NH benzene with NO2. This compound is known as 2,4-dinitrophenyl hydrogen. This compound is known as 2,4-dinitrophenyl hydrogen. Okay. So the same manner of the answer, that is C double bond N NH benzene NO2 group, means this compound, the product is known as 2,4-dinitrophenyl hydrazone, or it is known as 2,4-dinitrophenyl hydrazine or 2,4-DNP derivatives. It is a 2,4-DNP derivatives. Clear? And this is of the different color. That may be yellow in color, that may be orange in color. Those are different colors. It shows different colors. Clear? So these are some reactions that shows that aldehydes, when react with ammonia and their derivatives, it will form C double bond N type compounds with the elimination of water molecule. There are two reasoning questions. First reasoning question is why we use weak acidic medium, why we use the acidic medium, and the second question is why we can't be use the high acidic medium. Clear? So first of all, we start the first reaction, the first reasoning question, that is why we use the acidic medium. Actually, this CO group and this ammonia and the derivatives, when they react together, they can't be react easily. For the facilitation of the reaction, weakly acidic medium will be provided to this carbonyl compound. See here. C double bond O when react with H ion, weakly conditions means H ion is present. So these H ion first of all react with the lone pair of carbonyl oxygen, okay, and it will convert into, in this condition, this situation, okay. So as the oxygen get a positive charge, instantly the pi bond in between the carbon and oxygen, will be loose their bonding condition, and the pi electron will be transferred towards the more electronegative atom, that is oxygen atom, and the carbon contain positive charge. It means it will convert into this carbocation condition. Clear? Okay. Now easily weak base, these are all the weak base, ammonia derivatives, these are the weak base. Clear? So easily these weak base attack on this carbon atom. Okay. See here, C positive, O bond, H, like that ammonia and ammonia derivatives. This lone pair will be attacked on this position. Okay, it means it will show C bond N with 3H, O with a single H, and this nitrogen shows positive charge. So out of these three, any one of the hydrogen will be eliminated in the form of H ion by the losing of electrons towards this nitrogen atom. Okay, and this carbon will be converted into N bond H bond H bond O bond H. Clear? And after this compound undergoes dehydration, removal of the water will be takes place, and it will shows this compound, means the removal of water, OH and H. Okay, so by the losing of the one molecule of water, it will convert into C double bond N. So why we use the acidic medium? To facilitate the electrophilicity on carbon atom. Clear? We use H ion for electrophilicity on the carbonyl carbon. That is the first reasoning question. If we talk about the second question, why we can't use the highly acidic medium, means the pH range near about 1 or 0.5 or 1.5. So why we can't use the highly acidic medium? We very well know there are base, all these are base. So when if we have highly acidic medium, अगर solution में highly acidic medium provide हो जाएगी, clear, तो जो weak base है उन acid के साथ क्या कर लेंगे, react कर लेंगे, and they convert into salt, means this ammonia convert into NH3 plus H positive and convert into NH4 1 positive. Clear? And the X negative will be there. It means it forms salt. It will form salt. Clear? So जो further reaction का जो chances थे वो क्या हो जाते हैं, वो decrease कर जाते हैं, depress कर जाते हैं. That's why we can't use the highly acidic medium. Okay? So there are two reasoning questions. Why we use acidic medium and why we can't use highly acidic medium. Clear? So this is the part of the reaction of aldehydes and ketones with ammonia and their derivatives at near about 3 to, in between 3 to 4 pH, or simply we can say 3.5 pH. Okay, thank you students.